Hello everyone, how are you? I hope you are feeling well. So today I am discuss about 30 MCQ for the topic of acid base titration and precipitation titration. Let's begin with question number 1. Equivalence point of weak acid strong base titration. The solution is acidic, neutral, basic, highly acidic. Let's see which one is a correct answer. So correct answer is basic. When basic, the salt of weak acid undergo hydrolysis to produce OH minus ion. Let's see another second question. Another second question, what say? Which indicator is unsuitable for weak acid strong base titration? Let's see option. Phenolphthalein, thymolphthalein, thymol blue, methyl orange. So let's see which one is a correct answer. The correct answer is methyl orange. Methyl orange gives color change when acidic range. Only occurs in acidic range. Let's be some discuss about which type of indicator we use in acid base titration. So let's start with strong acid and strong base titration. In which type of indicator we used? First one is methyl orange. Second is methyl red. Phenolphthalein. Bromothymol blue. Phenol red. This is a indicator which we used in a strong acid, a strong base titration. Let's another see. Acid and a strong base. Which type of indicator we used? First one is phenolphthalein. Then thymolphthalein and thymol blue. Just you see in option A, B, C, which is mainly used for weak acid strong base titration, and other one is strong acid weak base titration. In this we used methyl orange, methyl red, bromophenol and bromo. Wait, just I erase this. Bromocresol green. Let's see last one, which is only used for weak acid and weak base titration. We used mainly mixed indicator. See a third question. Third question, the buffer region in titration curve indicates, means जो बफर का जो रीजन है, हमें जो टाइट्रेशन का जो कर्व किस तरह इंडिकेट करता है? ऑप्शन ए मैक्सिमम पीएच चेंज, साल्ट फॉर्मेशन, रेसिस्टेंस टू पीएच चेंज, एंड पॉइंट. Let's see a correct answer. Which one is a correct answer? The correct answer is resistance to pH change. When resist the presence of conjugate acid base pair, then resist the pH change. No change in pH. Let's see another question. Question number 4. Question number 4. Prefer primary standard for acidometry is option A NOH, KOH, oxalic acid, D option NH4OH, hydroxide. Let's see a correct answer. The correct answer is oxalic acid. Discuss about some acidometry and alkymetry titration. So in acidometry, we take a sample only basic drug such as which type of drug taking basis drug like acyclovir, ephedrine, etc. Let's which type of solvent we used? Only protogenic solvent like glacial acetic acid, oxalic acid. Mainly we used acid type of solvent we used in acidometry titration. Used in acidometry crystal violet. Crystal violet, which color change from violet to yellowish green. Yellowish green. And let's see in alkymetry titration. Alkymetry titration. In we use a sample acidic drug like nalidixic acid, fluorouracil, etc. Which type of drug we used? Only acidic drug we used for sample. In this, which type of solvent we used? Basic solvent we used like DMF, etc. Let's which type of indicator we used? Thymol blue. Color will change from blue to it's pinks to blue. And we some discuss about from acidometric and alkymetry titration regarding which type of indicator we used. So let's see. First one is a crystal violet. crystal violet. In acidic medium, bluish green. Then in basic medium means alkaline solution to form violet color. Okay. Second number, methyl red. In acidic produce red color. In basic produce yellow color. And we see another indicator, naphthol benzene. Green in acidic, yellow in basic. And last one is a thymol blue. In acidic, yellow. In basic, blue. See, let's see. And next question number 5. Question number 5, phenolphthalein transition range is, means what question से कि जो phenolphthalein का ट्रांजिशन रेंज होगा कितना से कितना होगा. लेट्स सी ऑप्शन ए 3.1 to 4.4, ऑप्शन बी 4.4 to 6.2, ऑप्शन सी 6.8 to 8.4, ऑप्शन डी 8.3 to 10. Let's see a correct answer. The correct answer is 8.3 to 10. The phenolphthalein indicator in alkaline medium, colorless to pinkish color form. Let's discuss about some indicator pH range. So first one is ethyl orange pH range 2.9 to 4.6. Okay. Then second one is methyl red. Its pH range is 4.2 to 6.3. And phenolphthalein range you see 8.3 to 10. Let's another one see bromo cresol green, pH range about 3.6 to 5.2. And methyl red, I think methyl red 4.2 6.3. neutral red range pH range you just see pH range around neutral red 6.8 to something 8 point. Let's see thymol Methylene pH range 9.3 to 10.5. Okay, learn it. Its most chance to comes in GPAT exam. So let's begin to next question. Question number 6. Morse method. Morse method is carried out at which pH? Option A less than 3. Option B 3 to 5. Option C 6.5 to 10.3. Option D more than 12. So let's see correct answer. Correct answer is 6.5 to 10.3. Which pH range we used to prevent chromate conversion and AGOH formation? So let's see in Morse method. In Morse method standardization which use AgNO3 plus NaCl which convert into AgCl plus NaNO3. Okay. Which type of indicator we used in Morse method? Potassium dichromate used in Morse methods and gives reddish brown precipitate. Okay, so let's see question number 7. In question number what say? Question number 7 what say? End point in Morse method is detected by AgCl, AgBr, Ag2Cr3, Ag2O. Let's see correct answer. Ag Ag2Cr04. It's mainly detect Ag2Cr04. Okay, just we discuss in question number 6. It's from reddish brown colored precipitates. So see the reaction like AgNO3 plus K2CrO4 which form Ag2CrO4 plus 2KNO3 which forms means then reddish brown precipitates form means end point is detected in Morse method. In Morse method we determine of NaCl, KCl, NaBr, etc. Okay. Let's see question number 8. In question number 8, what say? Bolhard's method directly titrate with option A chlorine, Ag silver, bromine, iodine. The correct answer is silver. Explanation: excess silver is back titrated. Let's see. In Bolhard method, what say? So like we use AgNO3 plus NaCl, then AgCl plus NaNO3 form. Okay, it's a standardization of AgNO3 by NaCl. Okay, then after addition of standardized AgNO3 in excess amount to give a back titration. So let's see a chemical reaction like AgNO3 plus KCl from AgCl plus KCl KNO3 wait plus KNO3 and AgNO3 means some amount will be remain. Okay. In Bolhard method, we used only for used to determine halogen, thiocyanide, etc. etc. Okay. Let's see question number 9. What's the question number 9? Ferric alum indicates end point by forming option A blue complex, green precipitate, blood red complex, white precipitate. The correct answer is blood red complex. Blood red complex when the form when ferric thiocyanide formation then form blood red complex. Then we determine the end point. Let's see question number 10. Question number 10. Acidic medium in Vollard method prevents AgCl precipitate, AgSCN precipitate, FeOH whole 3 precipitate indicated error. Which type of precipitate may be prevent during acidic medium? Let's see a correct answer. The correct answer is iron hydroxide precipitation avoided. Let's see a question number 11. Fajan method is based on redox, complexation, adsorption, pH change. Let's see a correct answer. The correct answer is adsorption. Adsorption. In Fajan method, we use indicator. The indicator adsorb on the formation of precipitate. Okay. In Fajan method, mainly we study about nature of adsorption. Like we discuss some indicator used in Fajan method. So let's see. In acidic dye we used as an indicator like fluorescein, iosine, etc. And in basic dye used as an indicator. So rhodamine series, rhodamine we used. And in okay, let's see next question. Let's say next question. Indicator for chloride in Fajan method. Option A eosine, fluorescence, ferriculum, K2CrO4. The correct answer is fluorescence. Why used in fluorescence indicator for chloride detection in Fajan method? So at the end point it's form pink color. Okay, let's see question number 13. Question number 13. Lowest solubility silver halide is AgCl, AgBr, AgI, AgF. The correct answer is AgI, silver iodide. Why silver iodide so lowest solubility in? Because its lowest Ksp value. Let's see question number 14. Question number 14. Argentometric titration use KMnO4, Na2S2, O4, AgNO3, EDTA. The correct answer is AgNO3. AgNO3. Okay. Another question, question number 15. Common ion effect suppresses solubility, ionization, conductivity, hydrolysis. The correct answer is ionization. The common ion effect suppress ionization because equilibrium shift backward. So let's see question number 16. Which type of indicator for strong acid and weak base titration? Option A phenolphthalein, methyl orange, thymol, naphthalene, alizarin, yellow. So what is a correct answer? We discuss in question number 2. So the correct answer is methyl orange. Methyl orange mainly used for acidic region. Let's see question number 17. Weak acid, weak base titration lack sharp end point because no reaction, small pH change, slow reaction, no indicator. The correct answer is small pH change. Why a small pH change? the minimum pH jump at equivalence. Okay, when weak acid and weak base is involved in titration, the pH range is very narrow. Weak acid, weak base, titration involve pH range is very narrow at end point. So identify the end point. It's require sharp color change. Okay, let's see a question number 18. Colloidal precipitate causes indicator error, personal error, adsorption error, instrument error. The correct answer is adsorption error. Why adsorption error? Surface adsorption of colloidal precipitate causes surface adsorption of ion. Okay, let's see question number 19. Question number 19. Normality depends on molecular weight, equivalent weight, pH, indicator. So normality depends on equivalent weight. Question number 20. Surface end point occurs in weak, strong, weak, strong, strong. The correct answer is strong. Why strong? Because it's require a large pH changes. Okay, it gives a sharp end points. Let's see question number 21. Why AgNO3 is secondary standard? Because impure, hygroscopy, unstable, needs standardization. The correct answer is needs standardization. Let's see role of K2CrO3 in Morse method, like adsorption indicator, internal indicator, external indicator, complex indicator. The correct answer is internal indicator. Why internal indicator? Just because present in titration mixture. Okay, 5% K2CrO3 potassium permanganate be used in Morse method as a internal indicator. Let's see question number 23. Methyl orange is red in neutral, basic, acidic, buffer. The correct answer is acidic. Why acidic? Low pH gives red color. Okay, जब हमारा pH काफी कम होगा तो लाल कलर का रंग प्रोड्यूस करेगा. मिथाइल ऑरेंज इंडिकेटर एसिडिक मीडियम में. So let's see question number 24. Accuracy of precipitation titration depends on temperature, stirring, low solubility, color. Its correct answer is low solubility. Why low solubility? To ensure quantitative reaction. Okay, let's see question number 25. Bollard method uses back titration. Just we discuss in previous question. Bollard method. Let's see option: slow reaction, poor endpoint, AgCl interference, unstable, SCN, thiocyanide. Okay, the correct answer is AgCl interference. Okay, let's see a question number 26. Primary standard for AgNO3 is NaCl, KCl, NH4Cl, calcium chloride, CaCl3. The correct answer is NaCl. In Bollard method, We used standardization of AJNO3 by NaCl. Why NaCl? It is a pure and stable. Okay. Let's see question number 27. Color change in Fajan methods occur due to complex formation, redox, charge reversal, hydrolysis. So let's see it. Correct answer is charge reversal. Why charge reversal? During a reaction in Fajan method, the surface charge inverse, like जो चार्ज हमारे नीचे रहेगा वो आके ऊपर हो जाएगा, मीन्स सरफेस पे आ जाएगा एब्जॉर्प्शन के कारण। लेट्स सी, आगे देखते हैं क्वेश्चन नंबर 28। क्वेश्चन नंबर 28 क्या कह रहा है? एंड पॉइंट इन एसिड बेस टाइट्रेशन इज इक्विवेलेंस पॉइंट, कलर चेंज पॉइंट, इनिशियल पॉइंट, बफर पॉइंट। द करेक्ट आंसर इज कलर चेंज पॉइंट। Why color change point? We use in acid base titration to determine the end point to detect by using a indicator. We use in acid base titration indicator at a end point. It gives change in color form to change a color. Okay. Let's see a question number 29. Buffer resist pH change due to buffer resist pH change due to high dilution, strong acid, conjugate pair, neutral salt. The correct answer is conjugate pair. Let's see a last question. Essential requirement of precipitation titration: slow reaction, reversible reaction, stoichiometric reaction, colloidal precipitate. Let's see a correct answer is stoichiometric reaction. Why stoichiometric reaction? Because it is a quantitative analysis. Okay, let's hope you understand so many questions. Let's next we discuss about next topics. Okay, thank you.